Imagine waking up one day and realizing that everything you believed about the world might be wrong. What if reality as we know it is just a fragment of a much larger, more complex existence? Today, we're diving deep into some of the most mind-bending discoveries that have shaken our understanding of reality to its very core. These discoveries are not just curiosities but profound insights that challenge the very fabric of what we consider real. The fragility of reality. Before we delve into the specific discoveries, let's take a moment to understand the fragility of our perception of reality. What we consider as real is often based on our senses, what we can see, touch, hear, smell, and taste. However, our senses are limited and easily deceived. Optical illusions, for example, are a simple reminder of how our brain can misinterpret reality. But what if these limitations go far beyond mere illusions? What if they extend to the very structure of the universe, the nature of time, and even our own consciousness? Quantum mechanics. The uncertainty principle. Let's start with quantum mechanics, one of the most challenging fields of physics. Quantum mechanics is a fundamental theory that describes the behavior of particles on the atomic and subatomic levels. One of the most astonishing principles in quantum mechanics is Heisenberg's uncertainty principle, which states that it is impossible to know both the exact position and momentum of a particle simultaneously. To put this into perspective, imagine trying to catch a baseball. In the macroscopic world, you can predict the ball's trajectory, speed, and point of impact with a high degree of accuracy. But in the quantum world, if you try to measure a particle's position precisely, its momentum becomes uncertain, and vice versa. This principle isn't just a limitation of our measurement tools. It's a fundamental aspect of reality itself. This principle challenges our classical understanding of reality, where objects have definite properties, independent of observation. In the quantum realm, the act of observation affects the system being observed. This is often demonstrated through the famous double-slit experiment, where particles such as electrons behave differently when observed, showcasing the wave-particle duality. The implications of this are profound, suggesting that reality might not be as solid and objective as we once thought. The Mandela effect. Collective false memories. Have you ever been absolutely certain that something happened, only to find out that you and many others were wrong? This phenomenon is known as the Mandela effect, named after the widespread but false memory that Nelson Mandela died in prison in the 1980s. In reality, Mandela was released from prison in 1990 and went on to become the president of South Africa. The Mandela effect challenges our understanding of memory and reality. It suggests that memories, which we often consider as concrete and reliable, might be malleable and even subject to collective alteration. Some theories propose that the Mandela effect could be evidence of parallel universes, where different realities coexist, and sometimes these realities bleed into each other. To give you an idea of the scale, in a survey conducted in 2019, over 30% of respondents recalled the famous Berenstain Bears children's book series as being spelled Berenstain Bears, a completely different spelling. While some scientists attribute the Mandela effect to cognitive biases and the fallibility of memory, others believe it could hint at something far more complex, a potential glitch in our reality or a sign of multiple realities intersecting. Time dilation. The elastic nature of time is another aspect of reality that is often taken for granted as a constant. However, the theory of relativity introduced by Albert Einstein revolutionized our understanding of time. One of the key concepts in this theory is time dilation, which suggests that time is not absolute but relative and can be stretched or compressed depending on the speed at which an object is moving and the strength of the gravitational field it is in. Consider the famous twin paradox. If one twin travels through space at near the speed of light while the other remains on Earth, the traveling twin would age more slowly due to time dilation. Upon returning, the spacefaring twin would be significantly younger than the Earth-bound twin. This isn't just theoretical. It's been confirmed through experiments with atomic clocks on airplanes and satellites. In fact, the Global Positioning System, GPS, has to account for time dilation effects to provide accurate location data. This discovery challenges our everyday experience of time as a uniform, ticking clock. It suggests that time is more like a flowing river, which can speed up or slow down depending on various factors. The implications are staggering, especially when considering the potential for time travel or the possibility that time itself might not be a fundamental aspect of reality but a construct of our consciousness. The holographic principle. The universe as a projection. One of the most mind-bending theories in modern physics is the holographic principle. This theory suggests that the entire universe can be described as a two-dimensional information structure, painted on the cosmological horizon, such that the three dimensions we observe are an effective description at macroscopic scales and low energies. In simpler terms, what we perceive as our 3D reality might be a projection from a 2D surface. The idea stems from the study of black holes and entropy. In the 1970s, physicist Stephen Hawking and others discovered that black holes emit radiation, which leads to a loss of mass and energy, eventually causing them to evaporate. However, this created a paradox because, according to quantum mechanics, information about the matter that falls into a black hole should not be lost. The holographic principle emerged as a potential solution, suggesting that the information is stored on the black hole's surface, not inside it, and this concept was later extended to the entire universe. This theory is supported by various mathematical models and has profound implications for our understanding of space, time, and reality. If true, it suggests that our perception of a 3D world is an illusion, much like a hologram, and that the true nature of reality is encoded in a two-dimensional surface. Simulation hypothesis. Are we living in a computer program? One of the most provocative theories that has gained traction in recent years is the simulation hypothesis. Proposed by philosopher Nick Bostrom in 2003, this hypothesis suggests that it's possible, even likely, that our reality is a sophisticated computer simulation created by an advanced civilization. Let's break this down. As computer technology advances, we're getting closer to creating highly realistic simulations of the world. Virtual reality, AI-driven environments, and even the concept of digital consciousness are becoming more feasible. If a civilization were to continue advancing at this pace, it's conceivable that they could create simulations so complex that the inhabitants, us, would be unaware they are inside a simulation. Bostrom's argument is based on probability. He proposes that one of the following statements must be true. 1. Human civilization is unlikely to reach a level of technological maturity capable of creating simulated realities. 2. Advanced civilizations will lose interest in creating simulations. Or 3. We are almost certainly living in a simulation. In 2020, a study conducted by the University of Oxford found that the computational power required to simulate the entire universe down to the quantum level is far beyond our current technological capabilities. However, the study also noted that future advancements could make such simulations possible, reigniting the debate. If the simulation hypothesis is true, it would fundamentally alter our understanding of existence. Questions about free will, the nature of consciousness, and the purpose of life would take on entirely new dimensions. Dark matter and dark energy. The invisible forces shaping the universe. When we look up at the night sky, we see stars, planets, and galaxies. But what we see is only a small fraction of what actually exists. According to current scientific understanding, around 85% of the matter in the universe is dark matter, and about 70% of the universe's total energy density is dark energy. Together, dark matter and dark energy make up about 95% of the total mass energy content of the universe, yet they are invisible and undetectable by conventional means. Dark matter does not emit, absorb, or reflect light, making it invisible to current telescopic technology. However, we know it exists because of its gravitational effects on visible matter. For instance, the rotation speeds of galaxies and the way light bends around them, gravitational lensing, cannot be explained by the observable matter alone. Dark energy, on the other hand, is even more mysterious. It is believed to be responsible for the accelerated expansion of the universe. Observations of distant supernovae in the late 1990s revealed that the universe's expansion is speeding up, not slowing down as previously thought. Dark energy is the leading explanation for this phenomenon, but its nature remains one of the biggest mysteries in modern cosmology. These discoveries challenge our understanding of the universe. We are essentially living in a universe dominated by forces and matter that we cannot see or fully comprehend. This raises profound questions about the limits of human knowledge and the true nature of reality. Consciousness and the hard problem. The mystery of the mind. One of the most perplexing aspects of reality is consciousness, the subjective experience of being aware and self-aware. Despite advances in neuroscience and psychology, the nature of consciousness remains one of the greatest mysteries in science. This is often referred to as the hard problem of consciousness, a term coined by philosopher David Chalmers. The hard problem differentiates between the easy problems of consciousness, such as explaining how the brain processes information, how it controls behavior, or how it reacts to stimuli, and the hard problem, which is explaining why and how subjective experiences arise. For example, why does the experience of tasting chocolate feel the way it does? Why does seeing the color red produce a different experience than hearing a musical note? Some theories propose that consciousness might be a fundamental aspect of the universe, much like space, time, and matter. This idea, known as panpsychism, suggests that consciousness could be a property of all matter, not just brains. If true, this would imply that even elementary particles have some form of consciousness, albeit at a level we cannot currently comprehend. Another theory, the Integrated Information Theory, IIT, suggests that consciousness is a product of the integration of information within a system. According to IIT, the more interconnected and integrated the information, the more conscious the system. This theory provides a potential framework for understanding consciousness but does not fully solve the hard problem. The study of consciousness challenges the materialist view of reality, which posits that everything can be explained by physical processes. If consciousness cannot be fully explained by brain activity alone, it might suggest that there is more to reality than the physical world, a notion that has profound implications for our understanding of existence. Time crystals. A new phase of matter. Time crystals are a relatively recent discovery that challenges our conventional understanding of time and matter. First proposed in 2012 by Nobel laureate Frank Wilczek, time crystals are structures that repeat in time, rather than in space. In other words, they are systems that exhibit a form of perpetual motion without consuming energy, defying one of the most fundamental laws of physics, the second law of thermodynamics, which states that the entropy, or disorder, of an isolated system always increases over time. In 2016, researchers created the first time crystals in a laboratory setting. These crystals are composed of particles that move in a regular, repeating pattern without any external input. This discovery suggests that time itself can be a dimension in which matter can organize in a stable, predictable way, much like how crystals form regular patterns in space. The implications of time crystals are profound. They could potentially revolutionize our understanding of the laws of thermodynamics and open up new avenues for research in quantum computing and other advanced technologies. Moreover, time crystals challenge the conventional view of time as a linear, unidirectional flow and suggest that under certain conditions, time might have more complex properties than previously thought. The multiverse theory. Multiple realities coexisting. The multiverse theory is one of the most speculative but intriguing ideas in modern physics. It suggests that our universe might be just one of many, perhaps an infinite number, of universes that exist simultaneously. Each of these universes could have different physical laws, constants, and initial conditions, leading to vastly different realities. There are several versions of the multiverse theory. One is the idea of bubble universes, where different regions of space-time expand at different rates, creating separate, non-interacting universes. Another version comes from quantum mechanics, specifically the many worlds interpretation, which posits that every quantum event spawns a new universe, resulting in a constantly branching multiverse. The multiverse theory challenges the notion of a single, unique reality. If true, it would mean that everything that could possibly happen does happen in some universe. This raises profound philosophical questions about the nature of existence, free will, and the meaning of life. It also suggests that our universe, with its specific laws and conditions, might not be as special or unique as we once thought. The ever-evolving nature of reality. As we've explored these mind-bending discoveries, it becomes clear that reality is far more complex and mysterious than we can currently comprehend. From the strange behaviors of quantum particles to the possibility of multiple universes, each discovery challenges our understanding of the world and forces us to reconsider what we consider to be real. What's perhaps most exciting is that science continues to evolve, and with it, our understanding of reality. New discoveries are constantly being made, each one adding a new piece to the puzzle. While we may never fully grasp the true nature of reality, the pursuit of knowledge is a journey that drives humanity forward, challenging us to question, explore, and expand our minds. In the end, perhaps the most profound realization is that reality is not a fixed, objective entity but a dynamic, ever-evolving tapestry woven from the threads of our observations, experiences, and imagination. And in this ever-changing reality, one thing remains certain. The more we learn, the more we realize how much we have yet to discover.